Hey everyone, thank you for coming. My name is Pablo. I am part of the support team in Percona. Today we will be presenting PC Stat Monitor and how it helps to troubleshoot query performance issues, if you want. The first I would like to share with you is what this presentation is and what this presentation is not. This presentation is to share the extension. This presentation is for those who likes to get the raw data and build your own solutions, but it's not something like a monitoring tool where you will get the data already processed, right? So many times it will happen that you are running with a database and you have some performance issues, but they could be because different reasons. It could be because there is a slow query which is performing or is running an underperforming execution plan. It could be because there is a missing index. It could be because bad statistics or whatever. But time to time, there are other issues that are hardest to troubleshoot. For example, those where you have a query with a random execution plan. So sometimes it's properly running, but sometimes it starts underperforming. So what's the problem there? Sometimes it's difficult to properly understand what's going on when the execution plan is randomly switching from a good execution plan and a bad execution plan, right? Sometimes it could be because there is a very specific value in the data distribution which is hitting an unwanted execution plan, but sometimes the data distribution could be heterogeneous and it starts jumping between different execution plans. You start getting different execution times on the queries, and you cannot figure out the reason of that. So that's what PC Stat Monitors will help to troubleshoot, at least in this presentation, okay? So what we will be covering here is what's the main difference between PC Stat Monitor and PC Stat statements, because most likely every working in Postgres is using the PC Stat statements. We will cover the installation options, the customization, how to troubleshoot and what could we troubleshoot with PC Stat Monitor, some extras that will provide some additional improvements, and we will cover the limitations on the feature, on this extension. Okay, first of all, what are the main differences between the PC Stat Monitor and the statements? If you worked with the PC Stat statements, I would say that it's an amazing tool. It provides a lot of information, but it also could mislead some decisions. If you are working with PC Stat statement, you will know that, or you will quickly figure out that it aggregates all the information in a single row, right? For example, if you have some specific query, you will get all the executions for that specific query over the time, right? So if the query is jumping between different execution plans and you have a specific execution plan which is running under 10 minutes, and then you have a good query execution plan which is running under 1 second, the values in the PGStat statement could mislead the solution, because the averages will be not completely useful. The maximum and minimum execution times will be not completely useful. You will get the number of executions for that particular query, but at the very end, you will not know how many of them run with the good or the bad execution plan, right? So, one of the things the PGStat monitor will introduce is the concept of bucket, right? PGStat monitor is storing the data into different buckets. You can configure the number of buckets, so you can store as much information as you want, but in terms of buckets, in terms of window times, if you want, right? So you can split your data in different buckets, and those buckets could say 1 minute bucket, 1 hour bucket, 1 day bucket, or whatever you can split your information. We will get a bucket start time column and a bucket done column, so you will quickly figure out what's the time for those queries and those execution times and so on. All the information will be split between buckets. Yeah. It's the time where it completes. And okay, the other important columns I would like to share in this presentation is the plan ID and the query plan. Okay, those are columns not included on the PGStat statement and are the main improvement if we compare both of the extensions. But you also need to know that there are a couple of columns present on the PGStat statements which are not included on the PGStat monitors, and those are related to the wall information. So what we will cover today are, or what we will be taking care today are the bucket start time, and the query plan. Those will be the useful in this session. In terms of the installation, this extension is not different than PGStat statements. We have a library which needs to be installed. The installation could be done through Jump repo or ABT repo or whatever you are using as repo management. You can do it through PGDG repo, PGXN, or you can build from source if you want. And once we have the binaries already installed on the server, in the same way we do with the PGStat statements, we need to load the library in the shared preload libraries, and we need to restart the database to make the database load that. Once the database is restarted, we just need to create the extension, which will provide some interface, some SQL interface to interact with the extension. Once we have everything set, we can check the PG settings view, and we will get a couple of new parameters which can be covered under the name PGStat monitor, and whatever the parameters we want to tune. Those parameters can be easily set in the same way every other Postgres parameter, right? It could be set through set commands, alter system commands, or even through the Postgres configuration files. So what's what we will get? Let me. Okay, we can get any query running on the database. In this particular case, I am checking for a particular query. So one of the parameters you can tune in the PGStat monitor is if you want to see the bind variables you are using on a specific query, or if you want to see the placeholder, right? So what's the advantage? If you are trying to get information from a particular query, it will be always easier to summarize all the executions under the same statement. So you want to avoid to store so many queries which are exactly the same but using different bind variables, right? Bind variable values. For example, in this case, we are storing streets, so I want all the queries which are performing a select star over the address, where address is something, whatever. Otherwise, if we store the bind variables values, we will get thousands of different queries which are exactly the same. And that you can turn on or turn off the parameter, and you can do it depending on what you are looking for. Initially, most likely, you will want to work in this mode, and then if there is a particular value which is hitting a problem, you want to switch to the other mode which allows you to track the bind variable values, okay? So we can check the number of calls for a particular query execution, and we can figure out other interesting values such as the execution time, mean time, maximum, and even the percentage that specific query represents over the total execution queries in the database. But at this point, at this specific point, we are running with the same problem than PGStat statements, right? Because if we are hitting several different execution plans with different number of scanned rows, the mean value will change through those execution plans. So what we are seeing is not false, but it's not something very useful for troubleshooting. It will happen exactly the same with the maximum, and eventually even with the mean, right? If we have very different numbers, the average is not something we can trust on. Other data we can get from that is the blocks we are hitting from memory or from disk, and also the percentage of blocks that particular query is hitting. Obviously, since this is an SQL interface, and we have the raw data, you can build your own queries and retrieve all the information you think is useful for you. So at least for me, working in support, that's very useful. I don't need to trust on graphs that maybe I didn't build and I do not trust on. I don't need to rely on whatever I am getting from AWS or different tools that maybe could be hiding some information. So we can get exactly the same information for the local blocks, which mainly refers to the temporary tables. And at this point, the obvious question is, what is new here and what is the difference with the PGStat statement, because all what we saw is what we can get from there. So here we can see a couple of differences. If you take a look at the query column, I am getting a bunch of queries which are exactly the same. All of them are exactly the same. However, if we take a look at the right on the query plan column, we will see that we have different execution plans, even for the same query, right? So we have bitmap scans, we have index scans, and also sequential scans. So this is the kind of issues you could be running on a database, and those are the scenarios where people start complaining, my query usually runs in 1 millisecond, but eventually it runs in 10 seconds. And you can think that the person is crazy or not. We can investigate what's going on. But without the execution plan, it will be really hard to track that. What's the advantage, the real advantage of that? Because you can also get this information by enabling a deeper login on the Postgres side. We can track the statements, we can track the execution time from the Postgres log. But if you do that, first, all the information will be stored on the Postgres log, even with the checkpoints, even with the database restart information, with the connections and disconnections, if you are tracking that. So you are getting a big bunch of information all together, and it's hard to figure out when a query is changing the execution plan. And you also will need some bash scripting skills to properly screen all the logs through the time and retrieve the information you are looking for. In this way, you can just build a query over the database, looking for specific queries, looking for specific execution times or whatever you want to troubleshoot. So this is much more easy. Other additional information we can get from the view is, as I mentioned, the bucket start time. So this is very useful because it could be possible that you have something like some batch processing in the middle of the night, and you are inserting or updating a big bunch of information at that time. So after that, the execution plans could change, right? And let's say that 3 hours or 4 hours after that, you got another bunch of updates, the statistics were revealed, and then everything starts working properly once again. So once you join your business hours, you have a couple of complaints that something went wrong over the night, but you cannot figure out that over the day, even if you are actively monitoring the activity on something like the PC stat activity. Everything looks good on that. But storing the information through buckets and getting the bucket start time, we can figure out what's going on for specific hours, minutes, or days, depending on the time or the duration you are configuring for the buckets. We can also get the username of the query executor and the client IP, which could be also useful to track something that is coming from some specific application. Okay, so here we can dig a little bit more, and we can look for a specific query statement which was reported as an offender or a query which is failing, and we can get all the information we got with the PC stat statement, but we can figure out which ones are the real offenders. In this case, for example, we are looking for the execution times, and we can see that most of the index scans are running almost instantly. There is no waste of time there, right? We can see a total execution time, which is taking considerably amount of time, but if we take a look on the mean execution time, we will see that that one is running below the millisecond. So all of those we can assume that are properly running, but we have some bitmap heap scans and the sequential scans which are running or are lasting for so long. So we can easily figure out which ones are the plans which are taking so long. And we can get all the related information. For example, we can figure out the reason because the bitmap scan is taking so long. And that's because we are getting almost no information from the memory, and we are reading the information from disk, in this case, right? And it happens exactly the same with the sequential scan, because we are reading most of the information from disk, whether on the index scans, we are almost not reading information from the disk. Yep. Sorry.
So that first read is reading from disk, right? And the other one is from its enabled memory.
Are you referring to this column?
Yes.
Yeah, the shared block disk, the shared block hit are the blocks we are retrieving from the shared pool, exactly from the shared pool. The other ones, what you are seeing from shared block read, it could be both. It only means that the information is not coming from the shared buffers. So as Postgres relies on the file system cache, it could be possible that additional blocks not stored in the shared buffer are being retrieved from both, from the file system cache or from the disks, okay? But we could say that basically all the queries running with index scans, in this case, are retrieving most of the information from memory. And we shouldn't be worried about that, because also the execution time was very good. But for the other ones, we can figure out different things that we can tune. And we can try to figure out what's the problem and how to tweak that. From this one, okay, we can get the mean execution time and blocks and the rows per execution. This one is another tricky case that we can see on super cases, because sometimes we get what we already mentioned, right? Queries with unstable execution plans. But there are other times where some customers complain that a specific query is running with a specific execution plan, but even that, sometimes the execution time could be too long, right? And it's hard to figure out that. So if we take a look on this one, on that section, we will see a specific query, and all of them are using an index scan, right? So all of them are exactly the same. But if we take a look at the last one on that section, we will see that one of the queries, the last one, is taking much longer than the other ones, right? It's taking considerably longer than the other ones. So all of them are running exactly the same and using the same execution plan. But if we look very carefully on that information, we will figure out that the number of shared blocks we are retrieving is larger than the other queries using exactly the same execution plan. And the main reason of that is that we are retrieving much more rows per execution, right? So this specific query, even when it's hitting the same execution plan, it's hitting a specific bind variable value, which is retrieving much more records, whatever the reason. I mean, the data distribution could be completely different for every company, for every system. So that's not something we need to dig, but we need to properly figure out the reason, because something is changing the behavior, and we cannot easily see the root reason of that. And another useful information that the PGStat monitor is including is the CPU information, because sometimes you want to figure out how much time your query is spending on CPU. We have, let's say, three main reasons because a query could be underperforming. We could be using too much CPU, we could be using too much memory, or we could be using too much I/O, right? I would say that I don't know any other tool which provides this information from the database, right? Usually, if you need to troubleshoot something related to the CPU consumption, you need to go to the operative system and you need to figure out from there. You need to use whatever you want to use, top or I don't know, looking for specific bits or whatever. But also if you are running on some specific scenarios, if you are running on containers, maybe you are not able to retrieve that information very easily depending the user you are running on. Um, so, as you can see from here, we can get the user execution time and the sys execution time for every specific query running a specific index. And we can also retrieve the information per execution, right? Let me go back a little bit and share some information with you. Okay. Maybe you want to know the reason because we have so many queries, and the reason because we have so many entries and all of them are executing the same execution plan, because in this specific case we have one bitmap scan, we have several index scans, and we have sequential scans, a sequential scan at the end, right? But if you carefully take a look on the query plan, we are also tracking the bind variables we are using, right? So that could provide some information of what are the offending values. For example, in the example we previously saw, the one is using the index scan, but it's also taking much more time per execution. So you could see, you could take a look on the execution plan and quickly figure out which one is the offending value, right? So after that, you can do whatever or whatever you think is better to do. We can build partial indexes. We can exclude that from the investigation, or we can focus the investigation on that specific value. But retrieving the values which are hitting different plans is also valid information when troubleshooting. And let's review what are the extras that PGStat Monitor can provide. So sometimes we get cases from our customers where they are asking for something very specific, right? This specific query is underperforming and we need some assist to tune that. There are other cases which are a bit more complex, like what we mentioned, a query which is randomly changing the execution plan, and we need to figure out the root reason of that. And sometimes we have cases where our customers request for support on high CPU usage or support on high I/O usage or memory or whatever. So I would say that this extension could be very useful to figure out the candidates to tune. Or even if you are running as DBAs and you are not in charge of the query performance, if you want to delegate that to the developers, that is a valid point, but you will need to provide some clues to them. So the database is our responsibility, and we need to be very careful with the resource usage. So if you want to reduce the I/O or you want to reduce the CPU consumption, you need to provide the kickoff, right? You need to give them something to work with. And this one is something you can easily build. We can easily build the top 10 of queries per execution time. And Once we get the top 10, we can even include or exclude things that we already know that are not very important. For example, for this specific case, we can see the second query, which is taking 16 or almost 17% of the total time on the database. But if we take a look on the number of calls, we can see that the number of calls is very high, right? If we take a look, or if we get the individual execution time for every query, it doesn't make any sense to provide that to be tuned. It's a waste of time. But if we take a look on the first query, we can easily see that that query is taking a long time and it's executing only one time. So with this information, you can decide, hey, this query is it's executing only one time. If we are talking from the top one, I would say, okay, we need to tune that because it's taking 83% of the database, right? But if we take a look on the last one, it's taking less than 1%, and it's also executing one single time. So even if you tune that, the amount of resources we will be releasing is nothing. It's not considerable. So following the same concept, we can get the top 10 for shared blocks, the amount of blocks we are getting or retrieving from memory, right? And the number of blocks every query is retrieving from memory. We can get the number of blocks we are reading from disk or writing from disk, which could be also useful if we have some high write I/O pattern. And lastly, we can get the top 10 or the top whatever you want to retrieve for the CPU usage. So in this way, we can get candidates. I am not saying that all of them can be tuned or all of them are offenders or we need to work with, but we can very easily get a list of candidates to work with. And if we don't want to work with any of them, we can easily exclude the particular query by introducing an additional where condition, where excluding the particular query or the particular query plan or whatever we want. We can also build this kind of candidate list, but based on whatever the query which executes more than 100 times, because maybe we don't want to spend time on those queries which executes once a day, right? So this one I would say is useful information we can get for query troubleshooting. Obviously, this is the first part of the task. The extension will not fix the problem. The extension will not fix the underperforming query. That's something we need to investigate. But retrieving the information and getting the candidates, getting the offenders, is half of the job. And we need to cover, okay, what are the limitations right now? And I would like to say once again, right now. Right now, we can retrieve the information, or we can track the information for all the queries executed over the database. We will get all the inserts, updates, deletes, selects, whatever, we will get all the information related to the resource usage, such as the number of IO disk, the CPU usage, the memory usage, but we are not currently tracking the query plan for all the statements, okay? We can retrieve the query plan only for select statements. That's something that will change when building this presentation. We discussed that with the development team. They figure out that it's not so complex to retrieve that information for all the statements. So it's something that should be ready, I would say, in short or medium term, but we can take a look or keep an eye on the PGStat statement page, and we will figure out if something new is coming. Also, what are the limitations? Where the resource consumption is, the resource consumption of the extension is not a limitation, but it's something that you would like to consider, right? How much load will the extension introduce on the database? Over all the tests I personally performed, I couldn't find a huge difference between a workload executed with or without the extension. That say, I performed a lot of PGBench test, 2 hours PGBench test, and the number of TPS I got from that is something that we cannot consider as a difference. Even if I run two PGBench tests without the extension, I will get a different number of TPS. It will not be exactly the same. It will be very close between the tests, but it will not be exactly the same. And exactly the same happened with the extension. With or without the extension, I couldn't find much differences. But I ran a couple of PGBench, a couple of custom workloads, if you want. And after that, I was in sync with the development team, and they let me know that when comparing the numbers on the test they did, they found that there are specific workloads where it could be a bit harmful, if you want, or it could introduce a bit of delay. And they mentioned that PGStat statements is currently introducing a 7% of slowness, and PGStat monitor is introducing a 12% of slowness, right? So it's a bit higher than you can expect compared with the PGStat statements, but it shouldn't be something that will bring all the performance down. And as a disclaimer, something I need to be fair with you. Yes, when working on this presentation, we found a couple of bugs in different aspects. We found some differences between what the extension is showing or what the extension provides as information and what the documentation in the Percona page shows as documentation. For example, this presentation was completely focused on PGStat monitor version 2, right? But there was a version 1, and obviously the documentation was not rebuilt from scratch, it was updated. So when looking and testing over the extension, I figured out that there were some issues. For example, if you take a look on the PCStat statement for a particular parameter, for example, you can tune the maximum amount of memory the extension will allocate or will pre-allocate, right? In PCStat Monitor version 2, that number could be from 128 megabytes up to 10 gigabytes. Okay, you can pre-allocate that amount of memory, and that's what it will use. And the more you pre-allocate, obviously, the more information you can store. If you run out of that memory, you will not be hitting the database memory if you want. I mean, you will not be hitting more memory from the shared buffers or from other pools, but you will stop collecting information, and the extension will let you know about that. Once the extension is overloaded, if you set a very small amount of memory and you are running a very large workload, then it could be possible, depending on the settings, for example, depending if you are retrieving the query plan or not, because that's something you can configure. It's not something that you need to be, it doesn't need to be set enabled by default. So you can set that as disabled, and you will be consuming less memory. But if you enable all the features and you are running with a large workload, eventually you can hit the maximum of the pre-allocated memory. And if that's the case, you will get a message in the Postgres log, which will say that the maximum memory was reached, and you can do different things to tackle that: increasing the memory, resetting the view, and releasing all the information, or eventually there is no impact. So eventually, exactly, at that time you will lack of some data. That also depends on the duration of the bucket. If you set a bucket with a duration of, let's say, 1 hour, it's very long. And you can set the duration of a bucket and the number of buckets you want to store. So let's say you are storing right now 1 minute buckets for a week, right? So eventually, if you were running a workload larger than expected, and you overloaded the memory for a couple of minutes, the buckets will be recycled time to time. Once you filled all the buckets you already set, they will start to be recycled, right? So you need to wait some amount of memory is recycled for the older buckets, and you will get the memory back to you, and you will be collecting the queries once again. If you need to track whatever is happening right now and you don't want to wait for that automatic release, you can just reset the information and losing the older query information, but you will be tracking all the information of the current time where you could be running with a problem and you want to investigate. So we have a couple of documentation bugs. There is a security bug, if you want, when enabling the query plan by default, we are exposing the bind variable values, right? So as a DBA, you need to be very careful on who are the ones looking at that information, because if the information on the byte variables is sensitive information, we could be creating a security breach. That's something that is also reported as a bug report and will be worked in the future in terms of a flag. In the same way we do that with the statement could show the bind variable value or not. That's what we will try to do in the future for the query plan. And of course, optimization improvements is something that we can always find, and it's also something that will be work in the future. I guess this covered the presentation, at least the ones I wanted to share with you. So we have a couple of minutes if you have questions related. You want to know in the future? There you are, my personal email, not my personal, of course, my business email. So you can reach me anytime, and I will ensure that you get the answer for your questions. Okay?